Yeah, hi. So in this problem, we are going to solve permutation sequence problem, and the tag here is hard, but I'll make sure that after this video, you will wonder that why the tag is hard here. It should be easy or medium. Okay. So yeah, enough of the bragging. Let's move on to the problem statement. So if we see the example test case, let's understand the problem with the help of example test cases. So we have two things, n is equal to 3 and k is equal to 3. We have two variables with us, n and k. So n means that we have the numbers from 1 to n. Okay. Now what we have to do is we have to write the different permutations of these numbers 1 to n. And then what we have to do is we have to write all the permutation in order. In order means sorted order. So after that, what we have to return is we have to return kth permutation sequence. So for example, if k is equal to 3, then what we have to return is we have to return the third permutation. So for that, it is 213. That's why the answer is 213. For 4, there will be so many sequences. So I'm not going to draw these sequences. But let's see for the third test case when n is equal to 3 and k is equal to 1. So for that, the answer will be 1, 2, 3, as we can see it here as well. Okay, so this is the thing. Now, after reading the problem statement, the first task should be to see the constraints. The constraints are n is equal to 9, less than equal to 9 basically. So see, whenever the constraints are such low, then our mind should go towards recursion, backtracking, that direction. Okay, I'm not saying that whenever this is the case, the problem will be solved with the help of recursion, but there are chances that the problem is made for recursion only. Okay, so yeah. Now let's see here. So basically, if we see, let's understand the problem for n is equal to 3, k is equal to 3 only. So yeah, I'm not solving for n is equal to 3, k is equal to 3. I'm writing for n is equal to 4 basically. So we have four numbers here, 1, 2, 3, 4. So if we see that if we want to create all the permutations, then let's write the recursive solution. Let's think in the terms of recursion only, that for this particular position we have four choices with us. Let's say we selected one, so one is here, and now the choices are limited to 2, 3, 4. So now we are here, and now let's say we selected this 2, so 2 is here. Let's use a different colored pen. So 1 is here, 2 is here, then we selected 3 here, and then we selected 4 here. Okay, so this is one of the permutation. Okay, and by using these choices, we can create all the permutations, and there will be no problem in creating that because the constraints are so low that the solution will be within the time limit. Okay, so there will be no problem with terms of time limit if we create all the permutations. Now the second point is, do we need to sort the permutation? Then we have all the sequences with us. Now, do we need to sort these sequences? The answer is no. I'll explain why. Because see, if we use the choices in sorted fashion only, that is, first of all, we are using 1, then we are using 2, then we are using 3, and then we are using 4. Okay, so if we are doing it in this fashion only, then see, first sequence that we obtained was 1, 2, 3, 4. And let's say we are here, and in place of we have 3, 4 choices left with us. So instead of choosing 3, we are choosing 4, let's say. So 4 is here, and then when we reach here, we are choosing 3. Okay. So the first permutation that we created was 1, 2, 3, 4, and the second permutation that will be created will be 1, 2, 4, 3. Okay, and so on. So basically, if we will be using choices in the sorted fashion, then we don't need to sort the permutations after the permutation creation because they will be in sorted fashion only. So what we will do is we will create all the permutation, we will insert it into the vector, and then we will simply return the kth permutation present in that vector. So to return the kth particular permutation, we will simply write, let's say the vector name is sequences. So we will simply return sequences k minus 1. Okay, so I hope the logical part is clear to you. Let's move on to the coding part. So what we want is we want a vector in which we will be storing all the sequences. Yeah, so vector sequences, and we have to basically maintain a data structure which will tell us that this particular, did we include this one or not, did we include this two or not, because we don't want to use this one again and again in this vector, because this is a permutation, and in the permutation we have only unique elements, right? So for that reason we have to make sure that we are not using a particular number again and again. So for that, what we will use is we will use taken vector, and because the maximum value of n is 9, that's why taken will be of size 10 and initialize with false. Now we will write a fun function, and in the fun function what we will do is we will pass 0, we will pass n, we will pass taken, and we will pass sequences. Okay, so we passed all these things, and then after that what we'll do is we will return sequences k minus 1. So now you must be wondering that here I used integer, but the return type is a string. And in fact, we have the permutation of different strings only. So yeah, we can use string here, but because n is less than equal to 9, then see, let's say one of the sequences 1, 2, 3, 4, 5, 6, 7, 8, 9. So they, instead of using it in a string, we can use a integer as well, and it will be space efficient, and efficiency will be increased when we use integer in place of string. So for that reason only I'm writing int here, and when I'm returning, so I'll use toString function to return it. So now we are returning string here only. So let's write the fun function now. So the return type, first of all, the return type is void, then int I, int n, vector int taken, vector int sequences. Okay, now we have choices from 1 to n. Okay, we have n choices with us. I is equal to 1 till n. Then we have to ask whether we included this particular I earlier or not. So whether I took this element before or not in our sequence. So if not taken I, then only we will perform operations. And yeah, one more thing, in sequences we will be storing the current sequence, right? And to store the current sequence we will be needing 0 here, in which we will be basically including the different numbers. Let's say we are selecting 1, so we will be including 1 this in this particular number. Let's say then we are including 3, then we will append 3 in this number. Okay, so for that we need current here as well. Okay, now if it is not taken already, then we will take it, we will include it in our current. To include it, we will write current is equal to current into 10 plus I. Okay, here I will write end. Okay, now we will call for the fun function, and for the fun function we will write end plus 1 current n taken sequences. Okay, now we took it, now we have to backtrack as well. So taken of I is equal to 0, and we have to remove the last digit of the current, right? Because we included the I digit here, and now we have to remove it as well. So for that we will write current divided by 10. Okay, so now it is removed. So see, some people have doubt that why we are writing this statement, why we are writing backtracking statement. So we do this because let's say we are at 1 and we are selecting it. Okay. And then we will come to I is equal to 2 and then will be performing these operations again. But the current value is, let's say earlier it is, let's say 0. This is a comment basically. Earlier value is current. Earlier value of current is 0, but when we were performing operation for I is equal to 1, then we updated it with I is equal current is equal to 1. So now we want to backtrack it to 0 because when we will be including for I is equal to 2, then the value of current is 0 only, right? For current is equal to 0, we have multiple choices. When current is equal to 0, there are multiple choices that we will include 1, we will include 2, we will include 3, and so on. So for that, we don't want to change that. For that reason only, we write this backtracking statement. And now we are done with these choices. Now we have to write the base code. Sorry, base case. So if int is equal to n, then we will insert this current in the sequences vector. And after that, the most important part is the return statement. And yeah, now I think it should work fine. Okay, there is a problem. I have to include a comma here. Yeah. Okay, here it should be bool. Yeah, it is working fine. Let's submit our solution. So yeah, our solution is accepted. And I hope you got the concept right. It is basically, yeah, it's a basic problem of backtracking, we can say. Okay. What we did is we used choices. We used the choices in such a fashion that we didn't require the sorting at the end. Okay, because we generated the sequences in sorted fashion only. Okay, and we used taken for uh, for making sure that one is not included multiple times. And yeah, overall the problem is good. It's a good implementation of backtracking, and if you understand this problem, then you will definitely understand the concept of backtracking as well. Okay, and we used int here instead of string because string will be more costly in terms of space, and int is cheaper, so that's why we use the cheaper option. And yeah, I hope you got the concept. I hope you like the video, and I hope that my first statement that you will think that the problem should be easy in place of this hard. I hope that I justified that statement. Okay, so yeah, that's it from my end. We'll meet in the next video. And if you like the video, you got the concepts right, then do like it, subscribe it, and comment it. If you have any problem with the solution, then do comment it. I'll definitely reply to your comment. Okay, so yeah, bye then. We'll meet in the next video.